Okay, last question, example 10. Let's look at the question. Okay, read the question, look at the information. Apparently they didn't ask for bearing. Okay, they didn't give us a north line. So in this question, there's no bearing, but we will still have to deal with the 3D trigo in part B. Okay, 3-dimension trigo in part B. Part A is just a simple cosine rule, sine rule, and area of formula. Okay, let's look at part A, part 1. Is it sine rule or cosine rule? They're asking for distance AC. And AC is facing this acute angle 46 degree. You have two sides. So can you remember what did Mr. Liu say? If you have two sides and you have one included angle, what formula can you use or should you use? Yes, cosine rule. Two sides and one included angle, it will be cosine rule. So in part 1, we will apply cosine rule. And take note, AC, the angle that is facing AC is 46 degree. So we apply the formula AC square. Apply the entire formula. AC square equals to 45 square plus 85 square minus 2, 45, 85 cosine, because it's cosine rule, cosine 46 degree. Let's press your calculator. I need this value. This is the second working mark. Press our calculator, you should get 3935 point. Okay, let me write more lah. By right, 5 significant figure is more than enough. Alright, more. AC. More is good. Okay, but 5 significant figure is good enough. So 3935.863. Press your calculator. You should get 62.736. 5SF 62.7 meters, 3 significant figure. Okay, this is for part 1. We got the value 62.736. Now let's look at part 2. The size of acute angle ADC. ADC, let me change the color. ADC is this. It is facing AC, 62.736. What else do I know? I have 46 degree. I have 46 degree. Okay. 46, if I want to make use of 46 degree, right, then I will focus on the big triangle instead. Let me erase off this. I will not focus on 62.736. Neither will I focus on I will not focus on the small triangle. I'll focus on the big triangle. It's difficult to see because there's a line in between. So for part 2, if possible, you can draw out the triangle, the big triangle, ignoring the middle, so that you know what rule you can use. Okay, I ignore the line AC. Okay, otherwise many of you will make careless mistake. Because the 46, if you ignore the line AC, right, 46 degree is actually facing 70 meters. Then the angle that we want to find in part A, part 2 is actually facing 85 meters. This is obviously not cosine rule, because cosine rule we look for two sides and one included angle, or we look for three sides given. So this must be sine rule. So we have the angle and we have the side opposite of the angle. We can apply sine rule. Let's call this theta. Sine theta over 85 meters equals to sine 46 degree over 70 meters. Sine theta equals to sine 46 over 70 times 85. Press our calculator for the value. 0.87348. Theta equals to sine inverse 0.87348. I'll get 60.866 3 dp, 60.9 1 dp. That's for part 2. Now part 3. They want area of triangle BCD or CBD, which is the same lah. Okay. Alright, so I do have the triangle on the right drawn out already. What do I need? I only have these two sides. Okay. So for area of triangles, we need the half times the two sides, 85 times 70. Then we need to multiply by sine of this angle, this included angle. So let's do it here. Area of triangle CBD. Oh, before that I need to find the angle. Let's call this alpha for convenience sake. Alpha equals to 180 minus theta, which is 60.866 minus 46 degree. I got 73.134. So area of triangle CBD is half times base, half times half AB sine C, right? Half 85, 70 sine the included angle. Press your calculator. Get 2847.033. 3 significant figure 2850 meter square. 3 significant figure. Pause the video if you need. If not, we will proceed on to part B. Part B will be 3D trigo. Okay, this is further trigo. This is 3D trigo. Note 7C, which is this worksheet lah. Okay, further trigo is worksheet 6. Okay, so this question is quite interesting. Part B, a guard G walks from B to D in a straight line. Okay, so the path of the security guard is this. Walk from B to D. So he was walking slowly, and now the question is asking, find the distance of the guard G from B when he is closest to C. So as he's walking slowly, which position should I mark out such that it will be the closest to C? Which position? I hope you say it is the shortest distance. Is the perpendicular distance. Okay, this position is when the guard G is the closest to C, because this is the perpendicular distance. Alright, so on top of that, they're also asking, I mean, this is the position where he is closest to C, but they're asking for the distance of the guard G from B. So they are asking for this distance such that he is closest to C. Okay, so I fix this point where he's closest to C, but they want BG. They want this distance. So what can you see? How to find this distance? I cannot use area of triangle like the previous question. I have a 90 degree here. I have a 46 degree there. The 45 meters will not be useful. The 62.736 will not be useful as well. I have a 85, which will be useful. So part 1, let me withdraw. I draw a right angle triangle. A G, C, 85, 46, a B. I want to find BG. I hope you got it. BG is adjacent. 85 is hypotenuse. Okay, it's not opposite. 85 is hypotenuse. Adjacent and hypotenuse means cosine. Cosine 46 degree equals to BG over 85. BG is 85 cosine 46. .046 meters, 59.0 meters, 3SF. Okay, so I found BG. So again, let me repeat. When they say closest to C, it simply means shortest distance from C, which means perpendicular distance from C. Okay, part 2. A drone hovering 2.6 meters directly above A. Directly above A. Spies on the guard through a camera. What is the angle of depression of the guard from the drone when the guard is closest to C? So the guard stay put here because this part is when it is closest to C. So now the idea is there's a drone. How to draw a drone? Okay, a drone. Okay, is above A. He's looking down at G. The drone to the ground is 90 degree. Okay, so how to draw? B part 2, I'll draw this, the drone from A, looking at G downwards, 90 degree. Oh, I need AG lah. I will need AG because I know the drone is 2.6 meters above A. 2.6 meters. I just need AG. AG is BG minus BA. AG is BG minus BA. BG I just found this minus BA 45. $14.046. So this is 14.046. I want to find angle of depression. This is a bit tricky. Angle of depression is horizontal line to the line of sight. So it's the same as this. So later I need to explain using the reason of alternate angle. So let's start. I will say tangent. I've used theta already. So I'll use alpha or beta. Alpha I also use already, so I use beta. Tangent beta equals to 2.6 opposite over 14.046, which is adjacent. Beta equals to tangent inverse 2.6, 14.046. $10.487. 10.5 degree, 1 dp. That's not the end. Because beta is 10.5, I will say angle of depression equals 10.5 degree. Then you must explain because it's alternate angles. Okay, because beta is at the base of the triangle, but the angle of depression is at the top. So you must explain through alternate angle. Okay, that's the end for this example and the end for this worksheet.